The other day we talked about expanding polynomials. Today we're going to go in the opposite direction. We're going to go and factor them. So up here we had our factored form, parentheses, and then we expanded that into a polynomial in standard form. Today we're going to go from standard form and factor it to get factored form or intercept form. So just like how there were special patterns for expanding, we're going to reverse those and have special patterns for factoring. So one of them is the difference of two squares. If we have something squared minus something else squared, we can rewrite this as a plus b times a minus b. You need to be aware that there is no sum of two squares. So you won't have anything a squared plus b squared. This is not factorable. Okay. So plus means it's not factorable, must be minus to use the difference of two squares. Then we have perfect square trinomials, where we have a squared plus 2 times ab plus b squared. That one is kind of hard to see because this middle term can get very confusing. But if you recognize this, then this is going to be a plus b squared. And as you get good at using the shortcut to expand, you'll get better at doing the shortcut to factor. We also can do a squared minus 2ab plus b squared, and that's a minus b quantity squared. Now, you learned how to factor trinomials last year, either using the X box or the grouping, the magic numbers. You can still do that. This is just a faster way if you notice that they are perfect square trinomials. What I do for this pattern is I say, can I take the square root of the first thing? And can I take the square root of the last thing? And then ask myself, if I multiply those two together, the square root of the first thing and the square root of the last thing, and multiply it by 2, do I get this? That tells you if it's a perfect square trinomial. If you can't take the square root of that last term, then it can't be a perfect square trinomial. We have to go back and do something else. Now, the sum of cubes and difference of cubes, you're not going to see those very frequently. And it's just good to know that if we have two things cubed that are being added together, a plus b, and then it's a squared minus ab plus b squared. And then for minus, a minus b times a squared plus ab plus b squared. So it is a bit confusing because both of them have two pluses and a minus. They're just in different locations. Again, the more you use them, the better you will be at recognizing these patterns. Now, factor by grouping. If you have four terms, you want to look and see, is there a GCF of the first two? And is there a GCF of the last two terms? So for this one, if you take the GCF of the first two terms, which are the greatest common factor, we have an x squared, and then we're left with x minus 1. And then the second one, we say, okay, can we take the GCF of between 4x and negative 4? We can. It's positive 4, and we're left with x minus 1. If these two match, then we can do factor by grouping. We're going to factor out the x minus 1, and then we are left with x squared plus 4. You may be tempted to factor this, say, oh, it's sum of or difference of two squares. No, there's a plus sign there. So this is as factored as you can get. Lastly, the difference between a plus b cubed and a cubed plus b cubed. We kind of talked about this yesterday. You can't just distribute this cubed. You're going to get a completely different answer. Think about it. If a is 2 and b is 3, 2 plus 3 cubed is 5 cubed, or 125, where 2 cubed plus 3 cubed, that's going to be 8 plus 27, and that gives us 35. So those do not equal the same thing. So these two, these are not equal. All right, let's look at our examples now. This one we have a to the third minus 6a squared. We can factor out an a squared from both of them, and we're left with a minus 6. And you can always double check your answer by redistributing. Right, a squared times a is a to the third. A squared times negative 6 is negative 6a. So I have my correct factorization. Example 2. All right, there is no GCF. So we can either do guess and check factoring, or we can do grouping. I tend to like grouping because it's a process, and especially when your C value is not a prime number, it can become more tedious to do guess and check. So when we do guess and check, I'm looking for two numbers that multiply to 2 times negative 24, or sorry, 2 times negative 12, which is negative 24, but add to negative 5. So we can do negative 8 plus 3, that is negative 5, and negative 8 times 3 is negative 24. So what we do is we break this up into 2x squared minus 8x plus 3x minus 12. You can switch the order of these two. It doesn't matter. I tend to, if I have the option of a negative one and a positive one, I tend to put the negative first. If you put the negative number second, then you got to factor out a negative, which is okay. So then I do grouping. I can factor out a 2x, and I get x minus 4. Here I can factor out a positive 3, and I get x minus 4. So that my final answer, my final factored form, is going to be x minus 4 times 2x plus 3. And like I said, if you want to do grouping instead, that's fine. Example 3. Again, you could do this one just like the previous problem. Multiply 4, add 9 to get 36. And say what two numbers multiply to 36 but add to our b value of negative 12. You could do that. I noticed that I can take the square root of that and get 2x. And I can take the square root of that and get 3. 2x times 3 is 6x times 2 gives you 12x. So that is a clue that this is a perfect square trinomial. Well, if this is a perfect square trinomial, I know that I can take the square root of the first term, so 2x, because it's minus right here, it's going to be minus the square root of my last term, 3 squared. And that'd be my final answer. But like I said, you could factor it the way we did number 2, and you get the same exact answer. Okay. Example number 4. Number 4 is not written in standard form, so it might be easier to rewrite this as 6x squared plus 35x plus 36. Okay. So now I'm going to ask myself, is there a greatest common factor, a GCF? Nope, there's no GCF. I can't factor a number out of everything. Then I say, is this a perfect square trinomial? Can I take the square root of 6x squared? No, I can't. The square root of 6 is not a whole number. So now I'm going to have to do what I did in number 2, guess and check, or say, what two numbers multiply to 6 times 36 is 216. So what two numbers is 36 times 6? What two numbers multiplied is 216 but add to 35? So let's see, we get 36. What if we do 36? 216. What if we do 216 divided by 18? We get 12. 18 plus 12 does not equal 35. So let's pick a smaller number. How about 16? Nope, 16 and 13.5. Let's do 14. Nope, 216 times, we don't want to do 12. What about 9? 9 and 24. If we add 9 and 24, we still don't get 35. So let's keep checking. Maybe 8. 8 plus 27, that does give us 35. So we need to break that up into 8x plus 27x. So 6x squared plus 8x plus 27x plus 36. Because if I were to add these two, it should go back to 35x. All right, so we're going to look here and factor out a 2x, and we're left with 3x plus 4. And then from the second two terms, we can factor out a 9. And we're left with 3x plus 4. These two match, so we know we are in good shape. 3x plus 4 times 2x plus 9. Our final answer. Okay, so example number 5, I see 16 and 9, and those are perfect squares. So we can use the difference of two squares, even though it's an x to the fourth. The square root of 16x to the fourth is 4x squared. The square root of 9 is 3, so I can write this as the product of these two terms. We then want to make sure that we can't factor either of these. Well, we look at that and we can't factor either of those, so this is our final answer. Number 6, this is the sum of two cubes because the cube root of 27 is 3. So we can use that formula where a is equal to x and b is equal to 3. So if we use that formula from above for our sum of cubes, it's going to be a plus b, so x plus 3, times a squared minus a times b, so 3x plus b squared, 9. We can't factor this any further, so that is our final answer. Number 7. Well, we can factor out a 2 first. So if we factor out a 2, we get 2 times 64x to the third minus 1. This is a difference of cubes, where our a in our formula, a is equal to the cube root of 64x to the third, which is 4x. And our b in the formula is the cube root of 1, which is just 1. So we're going to write this to our GCF that we factored out And then our formula is a minus b, so 4x minus 1, times a squared, 16x squared, plus a times b, so 4x, plus b squared, which is 1 squared, or 1. So we just used that formula, and that got us our sum of cubes factor. All right, number 8. Number 8, right now, we can't do much. Let's factor out a GCF. We can factor a 5 out of everything. So 5, and then we'll have 8t to the third minus 125b to the third. So then we want to ask ourselves, can we factor this? This is a difference of cubes. So our a value is going to be the cube root of 8t to the third, which is 2t. And our b value is going to be the cube root of 125b cubed, which is 5b. So then we can just use our formula. We have that 5. And then this is a difference of two cubes. So it's a minus b, 2t minus 5b, times a squared, so 4t squared, plus a times b, 2t times 5b will be 10 bt, plus b squared, which would be 25b squared. And we can't factor that any further. That gives us our final answer. Then number 9, if we look at that, we see what the heck is going on there. We have a lot of mumbo jumbo, but we have two things being added. We have this and we have this. And we ask ourselves, can we factor out a GCF? Well, they both have a 3x minus 1. This is 3x minus 1 squared, and this is 3x minus 1. So if we factor a 3x minus 1 out, that leaves us with 7 times 3x minus 1 to the first power, because we factored out one of these, plus 4 times 7 minus 2x. Now we have to work with this on the inside. So we're going to have to distribute that, combine like terms, and maybe even have to factor that. So 3x minus 1, distribute, we get 21x minus 7 plus 28 minus 8x. And then once we combine our like terms, our final answer is going to be 3x minus 1 times 13x plus 21. And that's our final factored answer. So our GCF can be a whole term. In this case, our GCF was this 3x minus 1 that we were able to factor out. All right, last problem here, number 10. We have 4 terms, so we're going to see if we can factor by grouping. These have an x squared in common and a y. So we're going to factor an x squared y. And in the first term, we have an x left over. In the second term, we have 4 left over. And here, the second one, 4x and 16. You would say, oh, you can factor out a 4. But because the front term is negative, we have to factor out a negative 4, which will leave us with x minus 4. Because for factoring a negative 4, this sign would have to change. That's how we get these to match. So then we'll finish factoring this. So we have x minus 4, and we have x squared y minus 4, and those would be our two factors. So hopefully this was a little bit of a review, and then we kind of kick it up to the next level, throwing in a little bit more variables. Factoring is something we're going to be doing all year, so we need to get a good grasp around it. So thanks for watching. Make sure to like the video and subscribe.